Hello. Hello, my name's Evan. Hey. My job is a site reliability engineer. It's what I do every day. It's what I've been doing for the last year and a half. Before that, I was a web developer, web designer for about 6 years, on and off, going through secondary school, college, stuff like that. And about halfway through college, I kind of realized that I prefer working with systems. I ended up becoming chairperson of Netsoc. We bought our first servers in 3 or 4 years and put them in a data center, and I really loved that. So much so that next year I became head sysadmin. And we went even further with 2 more physical servers and 2 VMs, thanks to UCC. The talk today is going to be kind of like what I do day to day, and the techniques we use and the design patterns of it. I really kind of wanted to do this because when I was in college, the only view we got of being an SRE or what SRE work entailed was from Google. And Google's view of SRE is very different to what actual SRE is. Despite them writing the book on it, it's completely different. And I honestly didn't know what to expect going into my first job. So I guess I should probably explain that this talk it's not really structured. I haven't written down what I'm going to say for each slide. I've basically done out 20 slides with kind of talking points and some bullet points. But mostly this is going to be an ode to the job I love, so it's going to be me rambling for the next 40 minutes. If you want me to stop at any point or ask a question or want me to explain something that I name dropped just out of thin air, that's totally fine. Just put up your hand, you can ask away. I'm totally okay with interruptions. It's not like I have a plan anyway. So what I do. So everything that an SRE does is maybe to combat system failure of some kind. Our job is pretty much entirely centered around failure. If you're not failing, the system's failing. So there's 3 things. And after a year of trying to explain my job to people who very much don't understand what the fuck I do, I've kind of distilled it down to if you're a technical person, these are 3 things that we do. We're monitoring to make sure that we can detect failure when it happens. So increased latency, nodes going down, our configuration management failing, stuff like that. Automation is the second thing. It's probably one of the biggest things we do, which is we try and, when something fails, automate the system or automate something else that can monitor it to fix it, basically. So when something breaks, we don't want to always be the one jumping in to fix it. Because often things will break in the middle of the night, over holidays, things like that. You don't want to be woken up at 3 a.m. on Christmas morning because, the latency is maybe 5 seconds too high. You want something to automatically handle that. And then the biggest part of our job, or the thing that actually we get paid more for, or we get paid danger money for, is incident response. And incident response is that 3 a.m. glitch. It's something has gone catastrophically wrong, something that we didn't foresee, and we can't fix automatically. And you have to fix it now. So you get a page as the on-call person, and you've got to respond to the incident. So Google have a good quote, which is, hope is not a strategy. Because it's very true. Everything's going to fail at least once. I think 2 weeks into my job, I had deployed a DNS feature we were going for, and I brought down our entire production service for about 6 hours. So I'm very grateful that I still have a job. It's great. But hope isn't a strategy, because things like a new hire going through the normal kind of induction process brought down our entire production service. We didn't foresee it. We didn't have a plan for it. And during those 6 hours, we identified 6 different issues with our system. So if all of those had been fixed, bar the thing I had deployed, we would have been back up in about 10 minutes. But because it went down, and then another issue happened, another issue happened, another issue happened, we ended up down for a very long time. And another great example most recently is, I'm not sure if you noticed, but last week, or was it the week before, GitHub went down for about 24 hours. And the reason for that was that one server went down for 47 seconds. And the knock-on effect of that server going down meant that for 24 hours, their entire service was pretty much unusable. And then even once they got things going back up, we were kind of like, we rely on GitHub for stuff, so we were kind of watching along. And once they were like, oh, we got to replay all of our webhooks and stuff, it was like, okay, cool. We know that's definitely going to bring down your webhook service, so we're just all going to go home for the day. And lo and behold, 2 hours later, oh shit, our webhooks, they've all been overloaded. Whatever will we do? And it took them another 4 hours before they were back up. So why do you need an SRE? It's because hope is not a strategy. You need someone to build the monitor, build the alerting. You need someone to build the automation. You need, someone to supervise the automation. And you need someone there in case like everything else has failed. You need a human person to intervene. So monitoring. Monitoring is pretty much graphs. There's kind of 2 halves to it, and I'll talk about the second half of what monitoring is in the next slide. But most of monitoring is building dashboards like this, which I'm sure make total amounts of sense to people who don't know anything about these statistics. And fun fact, these are all of our marketing slides. They're not meant to make sense. They're meant to look pretty. So most of monitoring is just using the metrics you pull out of your system and making graphs that you can kind of vaguely interpret information off of. But mostly monitoring is actually setting up alerts. So we have this thing that every 10 minutes it has a bunch of criteria it needs to look for, and it just goes through and checks all the criteria. And if any one of those criteria are off, it'll trigger a page or an alert to the on-call person. Generally, these are alerts that we can't automatically fix, or we have a set of non-critical alerts, which are like, hey, shit's kind of going wrong right now, but it might fix itself in 10 minutes, so we'll just leave it. And then if in 10 minutes it's not fixed, then it comes back and it's like, we need to page a person. Like a person needs to receive a call. So monitoring is just, it's alerts and dashboards. And the company I work for we provide these dashboards as a service, so I'm a little biased in that, I like dashboards. I like really pretty dashboards. In fact, here's a nerdy fact. Every week we pick a graph of the week, which is just a graph we really love. We're like, this looks cool. Unfortunately, one week I found a graph that looks like Batman and it wasn't accepted, which really sucks, I know. And then the second half of monitoring is something called observability. Observability is kind of like a new, it's not quite a buzzword in the SRE space, but it's logs. It's lots and lots and lots and lots of logs. And sometimes they're called events, because they don't always come from logs. But essentially what it is it's monitoring everything else about your system that you haven't a metric for. So it's like, something we track is, we have this cleaner script, and every time it deletes something, every time it cleans something up, it puts a log message, and we get those logs somewhere. So when something goes wrong, generally your monitoring will alert you to something, and it'll be like, oh shit, the latency between these 2 clusters is 50 milliseconds much higher than it used to be. Well then, what you can do is you can go through the logs and be like, okay, so I can see that it started getting connection timeouts out of nowhere, or that the packet encryption we had suddenly started failing to encrypt or decrypt the package, so it was taking longer. It's like every third package it can't decrypt. So observability kind of gives you the dimensions around a metric. So it's like you might have a metric to say what the latency is, but you don't know anything about what the program is doing. Or you might have a metric that says that that I'm accepting this many data points, and then when something goes wrong, generally there are tons of error messages in some log somewhere that tell you that this node is failing, or this program had a bug, or we suddenly stopped accepting post requests because someone made a typo and called them post, stuff like that. And observability gives you that kind of extra dimensionality. So you use monitoring to alert you, and you use observability to dig deeper. Observability is especially useful for digging deeper on production services. So I don't have to stop the server to know what the fuck it's doing. I can tell exactly from the logs, because we put output info logs of what it's doing at every step. Well, maybe not every step, maybe high throughput. But it gives you a lot more contextual information than just a number on a graph or a pretty graph somewhere, The pretty graphs are there to catch your eye and be like, that looks wrong. Observability is there to be like, here's a dense fucking amount of information, everything you'll ever need to know about the service and what it's doing right now. I did warn you it was going to be rambly for about 40 minutes, I'm sorry. So chat ops. So I kind of covered the monitoring element I talked about in the first slide. It's just 2 slides. Chat ops is this next section, like I think it's like 7 or 8 slides, is just techniques. It's design patterns we follow, tools we use. But so I'm not sure if you can guess from the title, but I built Dougal. Dougals basically are, I hesitate to call them an AI that sits in our Slack. He's basically a glorified command line interface. You tell him to do things, and he does things. For instance, here you can't see the command, but there's actually 2 commands here. But we told him to deploy a new version of our hosted graphite app. And it just goes through all of our various different, like what are called node groups, which are just houses for all of our servers. And it just goes, okay, I'm deploying it to this first, then this one, then this one, then this one, then this one, so on and so forth. Dougal is really useful for interacting with our infrastructure in a way that's consistent and version controlled, and that you will find it really hard to fuck up. Like, we manage a lot of our infrastructure through YAML files. Like, they're just a config file that sits somewhere in a GitHub repository, and like technically you can clone it and push or change that YAML file, and it will go everywhere into our system. But we abstract that by one layer through Dougal to get a couple things. One, like when it commits the change to GitHub, it's got a message we predefine. So we predefine different sets of messages for different actions. So like if you wanted to deploy a new version, it'll say, I'm deploying this version to these clusters, to these nodes. And you can go back into the GitHub history, and it's actually a log of all of the deploys. It's also really hard to fuck up because like he accepts command line arguments, which have predefined sets of like validation, where it's like if you, for instance, all of our project versions follow this this pattern, which is a build number plus the branch it was on. So if it doesn't match something like this, we can tell them it doesn't match something like this. You're deploying a version that doesn't exist. You're about to break production. You also get like a wide diversity of responsibility for people. We can give people access to specific things we want them to do in the servers without having to give them access to those servers. Like our developers have no access to our production environment. They have staging nodes, and they have access to like specific subsections where they need it. Same with support. Support has their own specific set of nodes. They can only access like a specific subset of our services. Only SRE have production access to like everything. So if we wanted to give them the ability to like say, what's a good example? If they wanted to clean up a staging environment, they'll need root access, which they don't have. So they can use Dougal to be like, hey, I want to clean up this node. So what it'll do is it'll remove all the, it'll put all the versions that are currently set for master into their thing. It will wipe the database, restart, and do a restore. It basically just gives them a clean slate. It's something they couldn't normally do. Or we have ways of performing traffic tracing at our front-end layer, which you obviously don't want people being able to SSH and do, because they can fuck that up in so many ways, and then suddenly your front-end's down and the entirety of your service is down. So it's a good way to kind of limit access in a way that's, nice, easy, and we can also monitor, because you have to use them publicly in Slack. So we also get this kind of like paper trail of like, if someone had a conversation and they were like, I want to do this action, you can see the action has been done immediately after the conversation. You get that kind of context with it. You get the kind of conversation around it. It's nice. Yeah, I really like Dougal. Sorry. I do really like Dougal. I could talk forever about Dougal. Like this design philosophy and shit. But the reason we built Dougal was because we had a bot that did a lot of this stuff. and a lot of these commands. It had all these kind of principles in it. But then it used IRC to communicate with Slack, and Slack said, we don't want that anymore. So within about a month, I had to just remake the entire thing. And yeah, I'm kind of happy with it, kind of proud. You don't know fear until you kind of like release a tool that has ultimate control over your infrastructure and like give it to people who you don't trust. To put it mildly. Like there is a certain tension between SRE and devs. Like we get along, we're very trusting of each other, but anytime we build something, it has to be foolproof, because the fools will just get smarter. So another a big thing is throughout our infrastructure is health checking. So when something fails, you want to know it fails, and you want to stop giving it traffic. You want to stop giving it like processing. So we have pretty much like all over our infrastructure is various sets of health checking. Some of them is just a web service, and the web service just listens to a port and reports back. It's like, yep, this is healthy. It's listening on the port. It's cool. It's cool. So when that port goes away, it can tell that the port is gone, and then it will report to something like we use this piece of software called etcd, which is a distributed key value store. So we essentially divide them up into groups, and in each group, we will give a list of healthy nodes. So then what we can do is we can say our front-end layer, or our load balancing layer, can tell which nodes are healthy, only direct traffic towards those healthy nodes. And if anything, like we poll anywhere from like every second to every 5 minutes, depending on how vital the service is. So like if we're polling every second to like test if the service is healthy, if it goes down, like the second it's gone down, that node immediately stops getting traffic, and we get an alert, or we get like a kind of like soft alert of like something's wrong with this host. We're taking care of it, but you should look at it eventually. I should mention a lot of times I'll say alert, but that doesn't always mean it's something you get called about or something you get paged about, something you get like an urgent response to. We have levels of alerts ranging anywhere from just like it's a Slack message somewhere, you should probably get to it, to a non-critical alert, which is like in predefined locations and you can get messages for them, and up to critical alerts, which are like shit's fucked, yo. So this is probably the biggest piece of automation we focus on, because we don't care so much about fixing problems if we can just direct the traffic away. Like we obviously have to fix the problem. Like you can't just not fix the problem. You just can't turn around and be like the problem's gone. But if the problem happens, we can just be like, it's okay. We can wait until business hours, 9 a.m. tomorrow, 10 a.m. Well, I start at like 11. But so 11 a.m. tomorrow, we can like deal with this problem. We can get into work. You're in your office, and you're not scrambling for your computer or anything. A lot of our work is based around doing that, is not having someone to have to deal with something at 3 in the morning or 4 in the morning, because it's hell. Like you get woken up, you're groggy, you open your laptop, you gotta like assess the impact. Pretty much the entire world is on your shoulders at 3 a.m. and you just want to sleep. So it's never a happy incident. Leading on from that, we have load balancing. So load balancing is a key part of using our health checking. It divides a lot of traffic across like layers of hosts, so that we can take a lot of traffic, we can handle a lot of traffic, but it also means that we have redundancy built in. So if something fails, we know we have like 3 or 4 extra nodes that we can just safely ignore that one. Yeah, there's not really much to be said about load balancing now that I put it in the slides. Yeah, load balancing is just kind of a thing you will encounter. It's very important, and but it's kind of simple. We use a piece of software called High Availability Proxy, which is just it's a piece of software. You plug it in, you tell it where to go. It's good, great. The health check is really simple. It's just like some declarations like Apache or whatever. I guess one thing that like HA proxy does not do well is it can't handle UDP traffic. So we're a monitoring service, so we get like a lot of data points, a lot of like metrics from places over UDP, TCP, TLS, TCP, stuff like that. So we got like evenly distributed across UDP, and it's really fucking hard with HA proxy because like it just assumes too much, and it has this thing where it always wants to make a connection. So like you route UDP through it, but it's still turning into TCP on the other end. You're like, no. So we have this other thing called it's LVS, which stands for Linux Virtual System, which is a terrible name because it does none of those things. But yeah, that's just a side note. HA proxy is great, but it doesn't have UDP traffic at all. So we have to come up with a different solution for that. Another thing is that, so it's really hard to load balance TCP connections, turns out, because someone can make a TCP connection and then just shove all their data down it forever. And what will happen is like, it'll connect to like one server, and then it will just flood your server with all of their data. And you can put rate limiting on and stuff. It's kind of hard. We ended up having to write our own kind of load balancer, our own layer, which leverages HA proxy, but it's kind of, it looks at a lot more of the context of our specific system to be like, yeah, this server's not getting enough connections or it's not taking enough data. So we're going to put all of our connections like mostly through that, and then just keep rotating as things go on. Yeah, that's load balancing. Distributed storage. This is probably a massive topic. I made these slides about a week and a half ago, and since then I think we've reimagined how we should do distributed storage for one service in particular, about 3 different times, because it keeps changing, and your requirements keep changing, and you want different things. Like etcd is actually an example of a distributed store. It's a key value store, so it just stores a key and a value. It's really simple, but it does replication across a bunch of hosts. It does load balancing across the hosts. If your host doesn't have the data, it sends it to the right host, stuff like that. And something, if you're interested in this kind of stuff, is the CAP theorem. So it's correctness, availability, and parallelization, I want to say. Sorry?
Partitionability?
Partitionability or something.
Yes.
It's something to do with partitions. I call it parallelization. Basically, we live on the internet, so you have to have P. That's a given. It just has to exist. You can't have one. You can't have one server handle all of your traffic once you get to a certain scale. So you need to kind of have this trade-off between, do I want my data to be correct, or do I want my data to be available? And obviously, it can be totally correct, but no one can access it, or it can be everyone can access it, but it's pretty much just giving you background of data. So there's this spectrum between C and A where you kind of make trade-offs to get what you want out of distributed storage, which is it's kind of a cool area, and I really like it. But I don't know anything about it. To be honest, we talk a lot about it, and the questions come up a lot, and I can give back the theory of computing answer to them, and that's happy enough for support. Something we also do is our main distributed storage for we take in all our data points. We got to put them somewhere. We got to store them somewhere. We store them for 2 years. Where the fuck do we put them? So we have this this custom built software based around this piece of software called React Core. We built it in Erlang, which is a language originally developed by Sony Ericsson for telephones. Voicemails, robotic messages, stuff like that. They used to all be made in Erlang. It's really to talk about Erlang for a minute because it's also kind of cool. One, it's a functional language, which is going to put off people immediately. Two, it's got its own VM like Java, so it's pretty much everyone else done. But Erlang is kind of really cool in that the way it's built is really nice. The way you can deploy software is really cool in a sense that it's built to hot swap itself. So obviously phone lines are incredibly highly available. You have to have the phone line available when someone calls. You can't shut it down for a minute and deploy new software and put it back up again. It just doesn't work. So they built this language to essentially be like, as each like process stops receiving traffic from the phone line, I will switch to the new software. So it waits until it's idle for each process to move over to the new software. So deployment still takes about a minute, but you're still serving all of your traffic through it that minute. It's also incredibly fast. Incredibly fast. It's really cool. We're also a Python house, so we don't build much in Erlang except when we need high throughput. Something, if you're interested in it, is there's this method of figuring out or of replicating the data across a bunch of clusters called the raft method, which is a form of consensus for determining like leaders and we'll just leave it at leaders because I can't think of the other thing. But yeah, if you're interested, cap theorem, raft, React are probably the three things away from this. Replication is a big thing. So we run MySQL in master replica. We're lucky enough in that we don't rely too much on MySQL. It's basically it's just our web app uses it for some things. We don't use it very heavily. So we can get away with pretty much one master and one replica. And the master can serve the entirety of our production traffic, no bother. And we pretty much just keep a replica in case something goes wrong. We can do a failover at a moment's notice. Like that's something Google will do for you. It's like you tell them, I want a failover from this database to this database, and yes, I'm definitely sure I want to do this in production. And it's actually a flag we have. And what it'll do is it'll just switch over the config variables and just be like, hey, you know that database you used to know? Don't care about it anymore. I want the slave to be the master there. Or the replica to be the master. Sorry, I'm really trying hard to get the slave vocabulary out of me. There's a big debate about that, and I'm totally okay about replica. So, it's really quick to just change the host address. We don't even hard code it. It's done through HAProxy again, which is just HAProxy looks at both of them and can automatically tell that oh shit, our master has stopped receiving writes, or it's returning errors, or we just can't communicate it with it, the port's down, whatever, and it'll start just sending traffic to the replica instead, and the replica will it's pretty happy to just take the responsibility of the master, just immediately, just kind of out of the blue. But often we like to, for our own sanity, explicitly define both. Just because it gets really, really weird when you're debugging problems and things are automatically happening and you don't know what's automatically happening, so you're just kind of yeah. Automation is great, but automation needs visibility. Automation needs a lot of visibility. Okay, so that was that section of automation, pretty much. As I said, probably the biggest part of the job, the reason I get paid quite a bit, is that I do incident response. So we have a rotating schedule. For us, we have 6 available on-call engineers. So once every 6 weeks, I do a week of 24/7 on-call, and it's from Thursday at 6 to Thursday at 6. So at 6 today, someone else took over from the last person. At 6 next week, the next person will take over. And then we have this benefit where you get the Friday off after your Thursday, because it's really stressful being on call, even if nothing happens. If nothing happens, that's actually kind of worse than something happening, because you have this pent up energy throughout the entire week, and you're constantly jumping at your phone every time it makes a noise, and it's really hard to sleep when you're on call. At least at the beginning, you kind of get used to it. You become a heavy sleeper if you're an S3, if that's something you want to do. Because, yeah, trust me, you either stay awake all night or you develop a heavy sleeping habit. Heavy sleeping habits, it makes it sound like I'm taking drugs. I'm perfectly healthy. So when you're on call, you're responsible for dealing with alerts. You're responsible for helping out support and your fellow development team, as well as building things for future on call, either bug fixing, feature improvements, new features, or new software. So being on call. So in this scenario, you're on call, minding your own business when your pager which is my phone. Generally, it's my pager. I'm going to refer to it as a pager, but it's my phone. The pager comes from doctors. Doctors who are on call for critical emergencies are holding a pager in a hospital. I think still to this day, they still use pagers. Basically, a mini cell phone that sends you a text message. So my pager is set up to send me a push notification immediately. It will send me a text after a minute, and it will call me after 3 minutes. So if I don't respond to the first one, it will go to the second one. If I don't respond to the second one, it will go to the third one. And if I don't respond for 30 minutes, it redoes all those things for me. Push notification, text message, call. If for another 30 minutes I don't respond, it will escalate it. So those 6 people I've mentioned that are on call, 6 including me, so that's 5 other people, they all get those things. So they get, depending on how they set it up, but let's assume they set it up the same as me, push notification, text message, phone call. If none of those respond for 30 minutes, it does them again, plus it will ring our CEO for 10 minutes straight. And it will also, up until about 2 weeks ago, it would also call the other co-founder, which no longer works for our company and lives in America, has no access to anything we do. But we realized for about a year, every time something really bad happened, because sometimes when a really bad incident happens, you forget to acknowledge the pager. And because everyone's dealing with the incident, they also forget to acknowledge it or whatever. So it just goes up. So he's been getting, he got I would say 3 pages in the last year for a company he no longer works at, a company he has no details for, a company he has no phone number to contact. But yeah, I'm sure he's happy. He lives in a ranch in America now. But yeah, so that's how the paging system works. It's like, if you don't answer, it keeps going, it keeps escalating. The idea is, by the way, after it gets to that stage, there's nothing above that. If we're at that stage, the company's gone bust, we're fucked. But yeah, the idea is that it will escalate and escalate and escalate. Generally, when you're in the office, the push notification is enough. We also get messages into our Slack channel, our main general Slack channel. So if you're on Slack, you'll see it before the push notification will even come in. And you just acknowledge it and it stops the escalation. It's fine. Okay, so your pager's gone off. Shit's hit the fan. Something's on fire. Everything's in chaos. What happens? So number 1, you got your page. You're the incident commander. So you're in charge of managing and delegating responsibility for the incident. You have to take control. There's one caveat. You can delegate it. You can tell someone else that they're the incident commander. And I mean tell. It's not a thing, who wants to be the incident commander? It's within 2 minutes, it's just okay, Dave, congrats, you're in charge of everything. I'm going to look at graphs for 20 minutes. And a part of the incident commander is you manage 3 or 4 different roles. One of them is the incident commander himself, or herself, or themselves, or whatever. And the second one is you have someone who is often the IC as well, who assesses impact to customers. So obviously you probably acknowledge the alert by the time you're shit, I need to do something. So number 3 is you assess the impact. Is this something I should tell our customers about? Is it something that is affecting our customers, or is it something we still have time to deal with? So we have, for instance, we have an alert that's our Redis memory is reaching, most of our servers have 64 gigs of RAM. So it's Redis is broaching 40 gigs. We should probably find out why and fix that. That's a critical alert because it's really important we fix that, but we still have that gap of 20 gigs to be we can investigate time, Next is you all, the kind of third role is you have someone who's doing exploration. Someone who's either debugging or digging through the code and digging through the graphs to kind of figure out what's gone wrong, can we fix it, how do we go about this. And 4 is you kind of just have, sorry, did I leave my jacket there? Oh yeah, you did, yeah. There you go. And so 4th, you have someone who's there to execute actions. Generally, you have many people doing role 3 and 4. is like, you'll have someone who's like, okay, cool, we need to restart like Redis across the entirety of our fleet. Someone's got to do that. So we have software that will let you do that, but like you have to have someone like, make the command, verify it with people, make sure that we're not, shutting off of servers by accident, which has happened before. But so number 4 then is like after you've assessed the impact, if you've status paged it or if you've done something, you need to work with role 3, which is the exploration person, and figure out how you're going to mitigate the issue. How do we get things back to a stable state? We don't care about fixing it right now. We care about patching it. We care about making it so it's like, okay, if something's gone wrong and we're just like, okay, we can just ignore this group and instead like redirect all the traffic to like some other cluster or some other like group or something, they can take it for like 20 minutes. It'll be a degraded service. It won't be able to keep up with the load, but it'll be there at like 9%. And that's totally cool while we figure out what the hell's going on. And then number 5 is we investigate the cause. So after we mitigate the issue, everything's kind of like established. We're happy that like this can, handle whatever we need to do, at least at a reasonable rate. We need to investigate what actually happened. Like, did someone fuck up somewhere, or was it something we didn't see, or like why didn't our automation kick in? Why didn't health checking kick in? Like, there's all of these questions you kind of got to go through in your head, and you just got to go through. Like after a couple of sessions of dealing with a really bad incident, you kind of just become into this, cool, I'm going to check the local log, I'm going to check the sys log, I'm going to go through Kamana, which is our observability software, go look through all the logs for all of the servers in the node group. Going to check what metrics it's outputting, how's the system metrics, is it like overheated, is the RAM gone, you'd be surprised. we don't deal with the highest quality of cloud providers, and some things go missing. Yeah. And so hopefully you've investigated the cause. You have an idea of what the cause is. Number 6 is, okay, so either we can solve the issue right now. If it's 3 a.m., probably don't want to solve the issue right now. For many reasons. One of them being you want to sleep, and sleep is great. So, or you can create a task for it to be solved later. Sometimes we kind of get to an incident and it's like, okay, this isn't an issue from us, from the SRE team. This is something dev introduced. So what we're going to do is we're going to roll back the version to something we're happy with, and we're going to deploy that everywhere, and then we're going to go back to sleep and leave a message for the devs to be like, yo, you fucked up, what the fuck are you doing, why you did this to us? Or a lot of times it's just like, okay, we kind of have an idea of what went wrong, but we need to verify it. We need to, go through all the steps of like testing a fix, of kind of like actually understanding what the problem was, because often things get clouded when you mitigate the issue. When you mitigate the issue, you put a patch on something, and often it's been like, okay, so we had an incident where like MySQL wasn't failing over right, and we needed to fail over. So we had to like perform a command in the MySQL server, and that fixed it. So someone, like it was late at night, someone created a ticket, was like, cool, you just got to put this command into our configuration management. Except if you run that command, it takes down MySQL for like 4 or 5 minutes, which is totally cool in the middle of an incident, because like you want it back up as soon as possible. But when you're failing over, to pretty much go from like instantaneous, I'm going to this one, no, I'm going to this one, to like, I'm going to this one, no, I'm waiting 5 minutes, I'm going to this one, it's not acceptable. So it's stuff like that. What you use to mitigate the issue is not often what you should use to solve it permanently. Whew. So, day-to-day on call. Outside of incidents and pages, what does on call actually do? Because a lot of people, it's something that surprises a lot of people, that like when you're on call, you just imagine this scenario of like every moment of every day is a page. Like I'm just constantly getting paged. I'm getting rung by like this robot voice. It's telling me what's wrong, and I'm just solving it immediately. And that's what a lot of people kind of like envisage when you tell them about on call. But realistically, 90% of my time is spent just improving the rest of on call. Like generally, what will happen is someone will have a really rough week of on call, like just incident after incident, and they got just a bunch of tasks in what we call the interrupt queue. And so they'll knock off on Thursday, and be like, I need to sleep for 3 days. So then you kind of roll in and you're like, cool. So on Friday you assess what needs to be done. You try and like estimate like what can I get done. And then Monday it's like, cool, I had a quiet weekend, no pages. I'm going to start in this intro queue. So you start fixing things. You start making like bug fixes, investigations, exploration. A lot of it's really bug fixes actually. It's just like, could we build a lot of software? It's really easy for things to kind of slip through the cracks. And I should say also, the majority of our time is spent tweaking alerts to be like, yo, this paged me late at night, but I couldn't do anything, so there's no point in paging me. A lot of the times, like there's situations where it's like, we experienced a network blip where a server appeared offline for a small period of time, maybe like a minute or two, and it just caused this kind of like this graph to dip. And we have an alert set up for that graph to dip. So, but like you come on, the network blip is gone, it's been like a minute, and you're just kind of sitting there looking at it, it's like, cool. I was watching a movie before this, but great. So it's just kind of dealing with redefining what actually wakes people up, what interrupts people's lives. Your job, if you have a quiet week, is to improve the lives of on-call after you. Because realistically, at some point, you're going to have a rough week. And you want the software to be as good as possible. You don't want to be up at 3 a.m. You don't want to be up, like dealing with an incident overnight. It's just not something you want to do. So it's your duty to you and the rest of your team to improve on call, unless you're a real dick. It happens. Some people, just like to continue with their projects. So I kind of reached towards the end. I don't know how many slides I have left, but I'm nearly done, promise. So these are things that I'll give you kind of like a cursory explanation of, but I won't go into detail about. So yeah, no rambling. So canaries. Canary is what you think of when you think of mines. It's something small that just like detects issues very early on. The idea is that you create a piece of software that pretty much just pretends to be a user, goes through your workflow. For us, we're a monitoring company, so we ingest metrics. So we have a canary for every protocol we accept metrics on. So just send us a metric once every second. So that's 60 metrics a minute, and we can tell that if it's sent us less than 60, then our service is degraded, there's a problem somewhere. And generally, canaries are set up to be alerted on because they're early indicators of something's going wrong, something's gone wrong, and it needs to be fixed. Service level indicators and objectives. If you ever look into SRE as a career, this SLISLO, this will pretty much become the acronym of your life. This is what it will be for 10, 15 years. And seriously, you can't escape these. And they're basically just their service level. And this is the metric you use to determine your service level. And this is the objective. It's what you want your service level to be at. So it's I want, a good example is Google famously says they provide 5 nines of availability. That means something 50 seconds, 3 minutes? Do you know off the top of your head? I don't know. It's less than a minute of downtime a year. And they're yeah, that's great. We can do that. Realistically, we serve 3 nines, which is something yeah, it's something it's in the hours range, which is still sounds per year. Whew, shit, man. You got 8 hours of downtime per year? That sounds hard. That is hard. It's really hard. Sorry, I might cry. But yeah, it's an objective. There's also another thing here. There's generally an SLIOA. And the A is your agreement, but that's kind of a business thing where it's hey, if we don't provide 3 nines of availability, you get to sue us. Great. And deployments. Deployments are a big part of my everyday, especially on call. You're kind of keeping an eye on who's deploying what software, how much deployments are going on, stuff like that. Currently, actually, my biggest project is redefining how we do deployments. So how we will do deployments is that Dougal will become an orchestrator where he'll look at the topology of the entirety of our of our infrastructure and be like, okay, cool, it's safe to like, restart this row of nodes all at the same time, and this row, and this row, and this row. And then it'll send the information into etcd, and then each of the nodes will like be like, okay, cool, I'm feeling like it now, I'm really in the zone, I'm gonna restart, and then it restarts. And the next one's like, yeah, it's not like I restart, I'm gonna restart too. So he restarts, and it goes on and on and on until everyone restarts and everyone gets the new software. So that's kind of how we will do deploys in a perfect world. I'm still building it and running unit tests, so maybe not. And so a bit about us as a company. So we're a monitoring company. Everything I also clarified every time. We monitor servers, not people. Promise. We don't do anything with the prison system. I've met several people in real life where it's like, yeah, I work for a monitoring company. We do monitoring, and they're like, oh, cool. How many prisoners do you have in your system? And we're like, hopefully 0. So yeah, we process 100 billion data points every day. It's kind of. When I started, and after a couple months, I'd been ignoring this dashboard in our office, which like puts up all the statistics, like how our server is doing and everything. And I was looking at, like I just making coffee. I was looking at it one day, and I was like, shit, we do. I can't give you the figure, but over 100 billion like data points a day. It's just like, shit, what? How? When? It feels like everything's down all the time, and they're like, no, it's grand. 100 billion is a lot. It's a lot of traffic as well. Like we process traffic in the gigabits per second into our network. We have, I don't think I'm actually allowed to tell you how many servers we have. We have thousands of servers as a vague figure. But I must admit every day I go in and I really love my job. And like, I look at kind of our statistics and I'm like, shit, 6 people can do this. It's kind of insane. Seriously, it's mind-boggling every day. I've been asked to say that we're hiring for developers, not SREs, unfortunately. I took the last SRE spot, so we're hiring for developers. Generally, we're looking for experienced developers at the moment. We just finished our internship recruiting, which Fiona is going to be on next summer. I think just summer, isn't it?
Yeah.
Cool. If you're interested in possibly being in Dublin and working for us, we do internships every year around September-ish. If you want to send us an email, or if you know someone who is a semi-experienced Python developer, we're currently hiring for one of those. And we pay quite well, actually. I was really surprised. My career gets paid quite well because the whole incident response thing, you gotta get paid well. But we pay our developers really well too, I found out, which is nice. It's always a good bonus. Before I finish up, so I really do love my job. And there's lots of different things, and one of the things that I feel like I'm obligated to point out is that our boss, our CEO, rides a motorized unicycle to work every day. It's probably the best fact about our company. To the point where I think he had to get a driver's license to make sure that he wasn't arrested on the roads. But if you ever see a YouTube video like around Christmas time or during the great snow, and it's like there's this insane guy running around on like a unicycle with like blue neon lights in it and shit. That's him. It pops up. He's the only one in Dublin, so it's really hard. It's really hard to ignore him. That's me. If you have any questions, you can find me. That's my Twitter. That's my everything. Brand Unity. Woo. And you can write me an email. evansmith@hostinggraphite.com. That's me. I don't have anything else. Cool. Thanks for listening. To explain that, by the way, it was like my third week, and someone was like, and the on-call person was like, I need to get a haircut, but everyone's sick or out or on holiday or whatever. And he was like, do you think you can handle a pager for 30 minutes? And it was like, I don't know. But yeah, once you get the first hit, I was straight into the on-call shift after that. Anyone have any questions? Any general comments? Anyone want to confess their love for me? No. Sean, now's the time. Okay, I'll leave you go.
We're a /page.
Have I? No. Thankfully, I was a light sleeper before I started this job, so that kind of helped. But I have been there when other people have slept through pages, which is an interesting experience because, like, obviously it goes through 2 cycles of like an hour, and then it goes to the rest of the team. So the rest of the team just hops on Slack, and we're like, "Where is it? What's happening? Where are you?" So yeah, it's interesting. I did once actually wake someone up accidentally at 4 a.m. because I fucked up time zones. It turns out time zones really hard. So we were meant to like mute the pager for a certain maintenance period or whatever. And our SRE manager was like, "Okay, it's like your first on-call shift. I'm not going to put you through that, like dealing with the issues or whatever if something arises." So I set up the schedule or whatever. He took the pager off me, and it was going swimmingly. And then like in the last 15 minutes of like, I think it was 5:15, he got a page, and he woke up and was like, "What am I meant to do, Evan?" And yeah, so he woke me up, and now my nickname is Mr. Worldwide. Yeah. Cool. Anything else? Anybody?
I was going to work the day after. Did you like up all night like fixing something? What's expected to be like? Or how does the rest of the week pan out?
So people are really nice in that, like, okay, so if you've been up all night, one, you get to sleep through the morning, and the first person into the office would be like, "Shit, you had a rough night. I'm going to take the pager for 2 hours," so that like you don't get woken up. Generally, it's like after a long incident, you'll go to sleep, but you'll still wake up at like 9, 10 a.m. So you come back into the office and you're groggy and shit. And someone generally will offer to just be like, "I'll take the pager for the night," and sort it out. If it's a really serious incident that spans like a couple of days, you're not expected to handle it all. Is basically how it goes. So if it starts in the middle of the night, obviously you have to deal with it, and you have to like rope people in or wake people up if necessary. But what will happen is we have a handover. So let's say you get paid at 3 a.m. and you're working, and it's like someone comes on at like 9 a.m. and they're like, "I'm in the office, I'm going to take over." So then what you do is you explain the situation, explain what needs to be done, and they become incident commander, and you go to sleep. And then what happens is, like, in 8 hours, if it's still going, what will happen is you'll have woken up, you'll probably be in the office at that point, or at home, generally active, available, and they'll be like, "I need to go home." So you're like, "Cool, I will become incident commander again." And they do the handover in the opposite direction of like, what's been done, what do I need to do, and it just kind of keeps going in those cycles. And generally, it's not between 2 people; it's split out amongst many people. So just because you're on call doesn't mean you have to become incident commander each time. Often it's rotated, and sometimes the best thing you can do if it gets escalated to the team at like 2 in the morning, and you see that like there are 2 or 3 people working on a problem already. Sometimes the best thing you can do is actually go to sleep, because if it's still going on in like 8 hours, you're slept. you're fresh as the daisy to like take over. So sometimes it's actually a good tactical decision to go back to sleep and ignore your page, is what I said to them. Yeah, you do have to be sure though that like at least 2 people go back to sleep. Because if one person go back to sleep and then they have to handle the entirety of the incident on their own the morning after, it's great. It's not great. But yeah, generally people are nice. They will take it off you. They will take off the responsibility. You'll be like, "You need time." And another side note is like one member of our team is having a child in a couple months, or next month, December, around the 6th, I think. And like he's not expected to be on call for like 3 months because he's on paternity leave or he's got a child. Or our manager specifically left the on-call rota because he has a child now. Like having a child is being like on call 24/7 with no handover. It's the worst. So obviously we don't expect people who like have children and who have really young children or just born and stuff to be part of this. But yeah, people are generally very nice. Quite like that. Cool. Okay, you can all go now. I'll release you back. Good luck. Have a good night.